Study Section 5, Estimation and Confidence Intervals. Introduction. Statistical methods of estimation are applicable almost anywhere in science, in business, as well as in other areas of life. In science, a biologist may wish to estimate what proportion of a certain kind of insect is born physically defective. In business, a finance company may wish to estimate what proportion of its customers plan to buy a new car within the next year. Furthermore, in driving, we may want to estimate what percentage of car accidents is due to faulty brakes. Basically, one may be dealing with the estimation of a percentage or proportion, average or mean and measure of variation. These, and particularly the first two, are the parameters with which we are concerned in most problems of estimation. You will learn about them in the next study session, but in this session you will learn the general principles of estimation. Learning outcomes for study section 5. When you have studied this session, you should be able to define estimation, distinguish clearly between point and interval estimation, list the properties of a point estimator. Estimation. A point estimate of a population parameter is a single value of a statistic. For example, the sample mean X is a point estimate of the population mean mu. Similarly, the sample proportion P is a point estimate of the population proportion P, interval estimate. Types of estimation. There are two types of estimation for a population parameter: point estimation, interval estimation. Point estimation. In point estimation, a single sample statistic such as X bar, S, or P bar is calculated from the sample to provide the best estimate of the true value of the corresponding population parameter, such as mu, standard deviation, or P. Such a single relevant statistic is termed as point estimator, and the value of the statistic is termed as point estimate. For example, we may calculate that 10% of the items in a random sample taken from a day's production are defective. The result, 10%, is a point estimate of the percentage of items in the whole lot that are defective. Thus, until the next sample of items is drawn and examined, we may proceed on manufacturing on the assumption that the day's production contains 10% defective items. One serious shortcoming of point estimates is that they do not tell us how close we can expect them to be to the quantities they are supposed to estimate. In other words, point estimates do not tell us anything about the intrinsic reliability or precision of the method of estimation which is being used. Therefore, point estimates should always be accompanied by some information which makes it possible to judge their merits. How this is done is the main concern in interval estimation. Interval estimation. For estimating a parameter value, it is important to know 1. A point estimate, 2. The amount of possible error in the point estimate, that is, an interval likely to contain the parameter value, and 3. The statement or degree of confidence that the interval contains the parameter value. The knowledge of these three pieces of information is called a confidence interval or interval estimation. Thus, an interval estimate of a population parameter is therefore a confidence interval with a statement of confidence that the interval contains the parameter value. The confidence interval estimate of a population parameter is obtained by applying the formula point estimate plus or minus margin of error, where margin of error is equal to ZC x standard error of a particular statistic. ZC is equal to critical value of standard normal variable that represents confidence level, probability of being correct, such as 0.90, 0.95, 0.99, and so on. An interesting feature of the formula for the margin of error is that it can also be used to determine the sample size that is required to attain a desired degree of precision. You will learn about this in Study Section 7. In-text question. There are two types of estimation for a population parameter: point estimation, interval estimation. In-text answer: true. Properties of a point estimator. The sample statistic value varies from sample to sample. Thus, the accuracy of a given estimator also varies from sample to sample. This means that there is no certainty of the accuracy achieved for the sample one happens to draw. Although, in practice, only one sample is selected at any given time, we should judge the accuracy of an estimator based on its average value over all possible samples of equal size. Therefore, we prefer to choose an estimator whose average accuracy is close to the value of population parameter being estimated. The criteria for selecting an estimator are: 1. Unbiasedness. The value of a statistic measured from a given sample is likely to be above or below the actual value of population parameter of interest due to sampling error. Thus, it is desirable that the expected value or mean of all possible values of a statistic from the estimate over all possible random samples is equal to the population parameter being estimated. If this is true, then the sample statistic is said to be an unbiased estimator of the population parameter. It can be shown that both X bar and P bar are unbiased estimators of the corresponding population parameters mu and p respectively. However, sample standard deviation S is not an unbiased estimator of standard deviation, but this bias reduces as sample size increases. 2. Consistency. A point estimator is said to be consistent if its value tends to become closer to the population parameter as the sample size increases. For example, the standard error of sampling distribution of the mean is equal to standard deviation over root n tends to become smaller as sample size n increases. Thus, the sample mean is a consistent estimator of the population mean. Similarly, the sample proportion P is a consistent estimator of the population proportion P because standard population is equal to standard deviation over square root of n. 3. Efficiency. For the same population, out of two unbiased point estimators, an unbiased estimator with smaller standard deviation is said to be efficient when it provides an estimate closer to the population parameter. It is for this reason that there is less variation in the sampling distribution of the statistic. Summary. In this study session, you have learned the following. 1. A point estimate of a population parameter is a single value of a statistic. For example, the sample mean X is a point estimate of the population mean mu. Similarly, the sample proportion P is a point estimate of the population proportion P. Interval estimate. 2. Two types of estimation: point estimation, interval estimation. 3. The confidence interval estimate of a population parameter is obtained by applying the formula point estimate plus or minus margin of error. 4. Properties of a point estimator: unbiasedness, consistency, efficiency. This is the end of study section 5. Thanks for listening.